This is a case where in the past, I would have automatically just thought, let's plug points into equations. And we totally can, and I'll do that at the end. It's fine. But in this case, because we have Desmos in the digital SAT, and I know how powerful it is and how all the features work, I actually realized that I'm given some points, and I just want to find the equation that matches those, the linear equation. So I can let Desmos do that using a regression. So I would just go there. So first things first, I would make a table, and I need to have an X and a Y. So the way the story is phrased, an economist modeled the demand Q for a certain product as a linear function of the selling price P, meaning that P is kind of like my X. That's the way to do it. So when they say the demand was 20,000 units when the selling price was $40 per unit, I want to think of that as a point where 40 is my X. And then because I don't want to deal with zooming a million miles to kind of figure this out, I'm going to go from 20,000 to just 20, and I'll deal with the conversion to thousands when I need to, right? I mean, look at the answers. I'm not going to be confused, but the answer once I have it, even if it's in thousands and not as it literally is. So 4020 is kind of this point here. Then 60 is my other X, and 15,000. So 15 is the value for that, and we can see those points if I zoom somewhere. It should be there. There they are, right there. So we can tell it to put the line between them by doing Y1, and then we need the tilde, and then we do M, and then X1 to tell it to go to the table, plus B. And now look, there you go. You got a line that goes through it. So there's the line, and if I scroll, we can see the equation. We got the M, we got the B. It's all good, but I don't care about that. I want to know what is the demand, so the Y, when the selling price is 55. So that's the X. So let's just do X is equal to 55. And there it is. We got a vertical line, and I care about where it intersects. It intersects at 16.25. Is that an answer? Well, yeah, because I converted, right? I know it's answer A. So, it took me 2 minutes to talk you through this. It would have taken me about 45 seconds to do that just myself if I'm just thinking in my head. So it actually is very efficient, but you got to know the buttons. You got to know what you're doing. If you had put in 20,000 and 15,000, you would have had to waste some time scrolling around. So you got to be smart as well and try to find efficiencies. But I like that. I feel like it's so much easier. I don't have to think very hard. So I'm saving brain power for later questions. I'm not, having any risk of maybe making a mistake. But I'll show you the way we could do it more traditionally. We would recognize that we want to do plug points into equations, that this story is giving us points. So the instruction is plug them in. Now, to what though, right? There's no equation, but we know that if they say it is a linear function, it's going to follow the equation y equals mx plus b. So if I find the m and I find the b, then I know everything there is to know. So the first thing to do would be to find the slope of the line. And again, we really want to know that the P is the X and the Q is the Y. It's a huge deal if we mess it up, but I do think it makes it a little bit weird to think about. So the slope here is then the change in Y over the change in X. So that's going to be 20,000. I'll just be literal again. 20,000 minus 15,000, right? So those are the two Y values. And then 40 minus 60. So we got to be careful with the slope there, but change in y over change in x, the slope, the m, is going to be 5,000 divided by negative 20. I'd go to this calculator for that. 5,000 divided by negative 20 is negative 250. So now I have part of this equation, but I don't have the b. I don't have a starting point. But remember, plug points into equations is that if we have an equation, plug in what you've got, we have points, right? So I have this 20,000, and then now I can plug in to solve for b. So 20,000 units is the y. That's negative 250 times 40, and that's going to allow us to solve for b. So negative 250 times 40 is negative 10,000. So 20,000 equals negative 10,000 plus b. So add that over. It's very tedious, but there you go. 30,000 is b. Now that I have the whole equation, which is y equals negative 250x plus 30,000, and I'm going to just double check that in Desmos. Does that make sense with what we put in? Yeah, negative 250, 30,000. So the conversion is there, but there you go. I like it. Now we can put in the value that we wanted, right, which is 55 per unit. That is the x value. So y is equal to negative 250 times 55 plus 30,000. Negative 250 times 55 is negative 13,750 plus 30,000. So plus 30,000 is y of 16,250. That's my answer. But oh my God, I mean, on the old SAT, you had no choice. You had to do that because you wouldn't have had the regression to be as easy as it is here. But I don't know. There's probably better ways to do it that involve algebra. You can probably find the slope, and maybe you can even be clever and be like, okay, the difference is 5,000. So if we were at 50 units, we would be at 16. We would be at halfway between. So that's 17,500. But then we're halfway between 50 and 60 at 55. So we want to take another half. So maybe some of you are going to get the 16,250 just by thinking about it. But I don't know. That feels risky. So I don't know. There's a lot of steps, but you might need to know how to do all this stuff that I did on the scratch paper in harder questions where maybe we don't have the points in a good way, or I don't know. I can't imagine, but there are cases where we're just going to need to plug points into equations like we did here. But if you've got the opportunity and you know how to use the regression, it's a very nice tool. So maybe learn it and look for opportunities to use it.